Hello. Okay, so I'm going to be talking about, like Denise just said, predicting trust in automated systems with regards to validation of the Trust of Automated Systems test, also known as the TOE scale, and that is how I will be calling it for the rest of this talk. So when introducing automated systems for the purposes of accomplishing tasks, for example, a military exercise, it is important to know how often humans will rely on those systems, and one of the key determinants of if a human will rely on a system is if he or she trusts that system. So we use this definition of trust that I'm about to say, adapted from research conducted by Nave in 2015, and that is trust of autonomous systems is a psychological state in which a person makes themselves vulnerable because they are confident that the automated system is capable and reliable enough to complete a task. So in 2019, a group of IDA researchers created a scale named the TOE scale to serve as a way to measure how much a human trusts an automated system. And since then, the scale has been initially validated in the context of analyzing human interaction with autonomous systems in military settings, but not as much in civilian settings. So by collecting a variety of responses of humans using systems, it's also possible to compare how groups of humans trust certain systems compared to others. Most of this trust level difference depends on risk associated with the task. So example, to name a couple of famous examples of automated systems, we have Apple's Siri versus Tesla's autopilot. In this case, Siri has comparatively less risk to the autopilot because Siri rarely, maybe never, can affect the life or death of the user, whereas autopilot can definitely do that easily. So we would say that Siri has less risk and a low penalty, and autopilot would have more risk and a higher penalty. So while the risk levels of these systems are vastly different, they definitely share the concept that the standard user does not fully understand the system that they're using, or the complexity of the system that they're using, or even the situations in which those systems are being used. So how do we measure trust of a system based on risk level? We use the TOE scale. So we determined that the two main components that correlated with higher level of trust were if the human understands what the system is supposed to accomplish and how well the user perceives the system accomplishes that task. So therefore, the TOE scale has two components. We have understanding and performance with 4 and 5 questions respectively. The 9 questions listed on the slide are given to the user in a random order, and then an analyzed version of their answers should predict how much that user will rely on that automated system. As I said before, this has been validated in the military context, and current research is working on validating the scale in the civilian context and a lot of other non-military contexts. So like Bill said earlier, you can find the TOE scale on testscience.org in our validated scale repository. Also, you can see the link there. And I will be floating around up organization team, so you might be able to see me at the poster session later. Next up, as we can see from the scale, understanding a well-performing autonomous system is the key to building the most effective human-machine teams. So widespread use of the scale in the defense community would allow us to, 1, better predict how operators will accept new autonomous systems, and 2, emphasize more human-compatible systems for combat scenarios. Whether the system in question is Siri or Tesla's autopilot or one of the many autonomous systems the military currently uses for tasks such as search and rescue or avoiding ground collisions, it is important to understand how compatible these systems are with human operators, both physically and psychologically. Thanks for listening again, and you can find our TOE scale at testscience.org in our validated scales repository.